What is the purpose of the M switch? Could you explain to me what the difference is between calling and? It seems in both cases my mod1.py is called and sys.argv is. So what is the M switch for?
The first line of the rationale section of PEP 338 says, Python 2.4 adds the command line switch M to allow modules to be located using the Python module namespace for execution as scripts. The motivating examples were standard library modules such as PDB and Profile, and the Python 2.4 implementation is fine for this limited purpose. So you can specify any module in Python's search path this way, not just files in the current directory. You're correct that Python mymod1.py mymod2.py args has exactly the same effect. The first line of the scope of this proposal section states, in Python 2.4, a module located using M is executed just as if its file name had been provided on the command line. With M, more is possible, like working with modules which are part of a package, etc. That's what the rest of PEP 338 is about. Read it for more info.
Despite this question having been asked and answered several times, for example, here, 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 and here, in my opinion no existing answer fully or concisely captures all the implications of the M flag. Therefore, the following will attempt to improve on what has come before. Introduction, TLDR. The M flag does a lot of things, not all of which will be needed all the time. In short, it can be used to 1. Execute Python code from the command line via module name rather than file name. 2. Add a directory to sys.path for use in import resolution, and 3. Execute Python code that contains relative imports from the command line. Preliminaries. To explain the M flag, we first need to explain a little terminology. Python's primary organizational unit is known as a module. Modules come in one of two flavors, code modules and package modules. A code module is any file that contains Python executable code. A package module is a directory that contains other modules, either code modules or package modules. The most common type of code modules are .py files, while the most common type of package modules are directories containing an _init_.py file. Python allows modules to be uniquely identified in two distinct ways, module name and file name. In general, modules are identified by module name in Python code, for example, import, module name, and by file name on the command line, for example, Python, file name. All Python interpreters are able to convert module names to file names by following the same few, well-defined rules. These rules hinge on the sys.path variable. By altering this variable, one can change how Python resolves module names into file names. For more on how this is done, see PEP 302. All modules, both code and package, can be executed, i.e., code associated with a module will be evaluated by the Python interpreter. Depending on the execution method and module type, what code gets evaluated, and when, can change quite a bit. For example, if one executes a package module via Python, file name, then, file name, /main_.py will be executed. On the other hand, if one executes that same package module via import, module name, then only the packages _init_.py will be executed. Historical development of M. The M flag was first introduced in Python 2.4.1. Initially, its only purpose was to provide an alternative means of identifying the Python module to execute from the command line. That is, if we knew both the file name and
module name. For a module, then the following two commands were equivalent: Python, file name, args, and Python m, module name, args. One constraint with this iteration, according to PEP 338, was that m only worked with top-level module names, i.e., modules that could be found directly on sys.path without any intervening package modules. With the completion of PEP 338, the m feature was extended to support module name representations beyond the top level. This meant names such as http.server were now fully supported. This extension also meant that each parent package in module name was now evaluated, i.e., all parent package _init_.py files were evaluated, in addition to the module referenced by the module name itself. The final major feature enhancement for M came with PEP 366.
With this upgrade, M gained the ability to support not only absolute imports but also explicit relative imports when executing modules. This was achieved by changing M so that it set the _package_ variable to the parent module of the given module name, in addition to everything else it already did. Use cases. There are two notable use cases for the M flag. To execute modules from the command line for which one may not know their file name.
This use case takes advantage of the fact that the Python interpreter knows how to convert module names to file names.
This is particularly advantageous when one wants to run stlib modules or third-party module from the command line.
For example, very few people know the file name for the http.server module, but most people do know its module name, so we can execute it from the command line using Python m http.server.
To execute a local package containing absolute or relative imports without needing to install it.
This use case is detailed in PEP 338 and leverages the fact that the current working directory is added to sys.path rather than the modules directory. This use case is very similar to using pip install e. to install a package in develop/edit mode. Shortcomings. With all the enhancements made to M over the years, it still has one major shortcoming: it can only execute modules written in Python, i.e., .py. For example, if M is used to execute a C-compiled code module, the following error will be produced: no code object available for module name. See here for more details.
Detailed comparisons.
Module execution via import statement, i.e., import module name. Sys.path is not modified in any way. _name_ is set to the absolute form of module name. _package_ is set to the immediate parent package in module name. _init_.py is evaluated for all packages, including its own for package modules. _main_.py is not evaluated for package modules. The code is evaluated for code modules. Module execution via command line with file name, i.e., Python file name. Sys.path is modified to include the final directory in file name. _name_ is set to _main_, package_ is set to none. _init_.py is not evaluated for any package, including its own for package modules. _main_.py is evaluated for package modules. The code is evaluated for code modules. Module execution via command line with module name, i.e., Python m, module name. Sys.path is modified to include the current directory. _name_ is set to _main_, package_ is set to the immediate parent package in module name. _init_.py is evaluated for all packages, including its own for package modules. _main_.py is evaluated for package modules. The code is evaluated for code modules. Conclusion. The M flag is, at its simplest, a means to execute Python scripts from the command line by using module names rather than file names. The real power of M, however, is in its ability to combine the power of import statements, for example, Support for explicit relative imports and automatic package_init_evaluation, with the convenience of the command line.
It's worth mentioning this only works if the package has a file_main_.py, otherwise, this package cannot be executed directly. The Python interpreter will looking for a _main_.py file in the package path to execute. It's equivalent to. It will execute the content after.
I just want to mention one potentially confusing case. Suppose you use pip3 to install a package foo, which contains a bar module. So this means you can execute Python 3m foo.bar from any directory. On the other hand, you have a directory structure like this. You are at src/. When you run Python m foo.bar, you are running the bar.py instead of the installed module. However, if you are calling Python m foo.bar from any other directory, you are using the installed module. This behavior certainly doesn't happen if you are using Python instead of Python m, and can be confusing for beginners. The reason is the order how Python searches for modules.
If you want to see more, please consider subscribing.